All right, so we're looking at Skill Packet 7, the review problems from Skill Packet 7. These next three problems, I believe, have the same directions. They've given us a sector. They've asked us to find the arc length, and they always let, it's common to let the arc length be represented by S, and I'm just going to let capital A be the area. And so I have formulas that if my angle measure is a radian measure, which in this problem it is, then I can calculate the arc length by taking the radius times that angle measure. And it's common to use the Greek letter theta for an angle measure. So if I'm trying to find the arc length S, I know that the radius is 20 centimeters. I know that the angle is 3 pi over 8. If I multiply these together, I get 20 and 8 share a common factor of 4. So that's 5 times 3, 15 pi. And I canceled out a 4, so here a 2. And this has lengths of centimeters. If you want to, you can go, I usually just give the exact answer, but if you want some decimal approximation, let's just approximate it to the nearest tenth, to 1 decimal, and 15 pi divided by 2. I'm getting an approximate 23.6 centimeters is the length of the arc of this sector. All right, what about its area? And again, I have a formula that if I'm given the radian measure of the angle, it's 1/2 times r squared times the angle measure, provided that angle measure is in radians. If it's not in radians, I'll have to convert it to radians. So my area, 1/2, r is 20, so we'll take 20 squared. And then we've got 3 pi over 8. So what, 20 squared is 400 times 3 is 1200 divided by 16. I don't know, let's go to the calculator. I don't want to. Alright, so my numerator, I've got 3 times 20 squared. Alright. Well, I didn't. I haven't very much. It's hard even. It's hard for me to see which buttons. There we go. 3 times 20 squared. I don't want to worry about the pi. Divided by, well, 2 times 8 is 16. 75. So don't forget my pi. 75 times pi. And area has square units, and if the units are centimeters, square centimeters. If I want a decimal approximation to that, to 1 decimal times pi, (235.6) square centimeter. Not square meters, square centimeters. And you can carry it out to more decimals if you need to. Like I say, I always used to just give exact answers, and then there's no question whether I'm right or wrong. I gave the exact answer. All right, so that's good for the arc length and the area for 20. Let's take a look at the next one, 21. So it's the same problem. It's the same idea. The angle measure is given to me in radians. So the arc length, S, is r times theta, where theta is in radians. Here they're giving me a radius of 3. Boy, this is lagging so bad. It's hard to even write. 5 pi over 6. So if I look at 3 as 3 over 1, you can see that 3 over 6 reduces to 1/2. That this guy is 5 pi over 2. And that has units of meters. If I want a decimal approximation to that, I can go to a scientific calculator, take 5 times, not having any luck with this, times, divided by 2. To 1 decimal, 7.9 meters. Now the area, the formula for the area, if my angle measure is in radians, is 1/2 r squared times this angle theta. That's what I'm calling theta, is the angle measure. And I've got 1/2 times 3 squared times 5 pi over 6. So 9 over 6, well 9 times 5, but then 9 over 6 reduces to 3 over 2, so 3 times 5, 15. And we said that's a 2, and 2 times 2, 4. Let's double check that and make sure that I haven't made a silly mistake. So if I've got 9 times 5 is 45, divided by 12, that fraction should reduce to 15 over 4. Yeah, okay. So that's in square meters. If I get a decimal approximation to that, let's take this 15 over 4 and multiply it times pi, and to 1 decimal I'm getting this 15 pi over 4 equal to 11.8 square meters. Alright, so I hope that helps.